Welcome to my YouTube channel, Physics Tips for IGCSE Students, where we look at the 0625 Cambridge IGCSE syllabus. Now, in today's lesson, we are going to look at Chapter 1, Length and Time. In this chapter, we are going to be focusing on physical quantities, units, and measurements. Now, at the end of this lesson, you should be able to show an understanding that all physical quantities consist of a numerical magnitude in the unit, and recall the various base quantities in their units, that is mass, length, time, current, and temperature. You should also use the prefixes and their symbols to show decimal multiples and submultiples of the SI units. Show an understanding of the orders of magnitude of size of common objects ranging from a typical atom to the Earth. Also describe to measure or how to measure a variety of lengths using different measuring instruments: the measuring tape, the micrometer screw gauge, the vernier calipers, and the meter rule. Also, we're going to look at time measurement, and in time measurement, you should be able to describe how to measure a short interval of time, including the period of a simple pendulum, with appropriate accuracy using stopwatches or appropriate measuring instruments. Now, in order to realize these learning outcomes, the lesson is going to be split into 3 videos. The first video is going to cover physical quantities and units, second on measurement of length, and the third one is going to cover measurement of time, including that of the simple pendulum that you're talking about. Now, a physical quantity is a property that can be measured. Examples are length, speed, mass, weight, force, pressure, time, and temperature. And I know you are able by this time to mention other physical quantities. Now, imagine you ask about the age of a person and the number is a numerical value. Now, if the person says she's 12, is it 12 months? Is it 12 years? Is it 12 days? So the information conveyed during the conversation will not be very specific and useful if there is no unit. Thus the need to specify the unit of measurement. Therefore, numbers do not make sense to physicists if they do not carry a unit. So in physics we say, no naked numbers, please. All numbers should have appropriate units. Now, looking at base quantities and units in detail, there are about 7 base quantities. The first one being length. The unit is the meter. The symbol is the small letter m. Second one is mass. The unit is the kilogram, and the symbol is the kg. Third one is the time. The unit is the second. The symbol is small letter s. The fourth one is temperature. The base unit is Kelvin, and the symbol is capital letter K, please. The fifth one, the current, the ampere, and then the unit is the amps, capital letter A, please. Now, the last 2 you're going to cover in the AS physics syllabus, that is the luminous intensity and the amount of substance. The unit of the luminous intensity is candela, and symbol is CD. Amount of substance, the mole, and symbol is MOL. Now, looking at prefixes, where you have very small numbers and very big numbers, you can make your life easier by employing prefixes. The example given there is that of the sun, which is about 149,342,000,000 meters away from us. Now, we could use prefixes to make our life easy, as well as bacteria, which is very small, which is about 0.000001 meter long. So we could make our life easier by employing prefixes to help us to name such big numbers and small numbers. The order is as follows from the smallest to the biggest. Nano means 10 to the minus 9. The abbreviation is small letter n. Micro, 10 to the minus 6. Milli, 10 to the minus 3. Centi, 10 to the minus 2. Deci, 10 to the minus 1. Kilo, 10 to the power 3. And mega, 10 to the power 6. As well as giga, 10 to the power positive 9. Now, when you are asked to change a unit with a prefix into one without, you simply multiply the number with the factor of the prefix. For example, if you are asked to change 400 milligrams into grams, you simply multiply by 10 to the power 3, which is represented in the prefix. 0.025 kilometers would then be 0.025 times 10 to the power 3, which becomes 25 meters. Now, these are some problems for you to try. Changing 5,500 milligrams into grams, 0.45 kgs into grams, 0.004 gbs into bs, 8,900 nanometers into meters. Now, starting with the 5,500 milligrams, right, you simply multiply the 5,500 by the number represented by the prefix, which is 10 to the minus 3, giving you 5.5 grams. Now, you do the rest. Now, if you are asked to change a unit without prefix into one with prefix, you divide the number with the factor of the prefix. For example, 3.9 meters changed into centimeters, you simply divide by 10 to the power minus 2, and you get 390. 5,000 hertz into megahertz, you divide by 10 to the power 6, which is 0.005 megahertz. Yes, some problems for you to try. Right, the first one there is 250 grams into kgs, 0.000345 meters into micrometers, 45,600 hertz into megahertz, 0.765 amps into milliamps. So just remember that you just divide by the number represented by the prefix. Now, the last bit on this video, the part 1 video, we're going to show some estimations. You should be able to estimate the diameter of an atom to be about 10 to the minus 10, and the diameter of the Earth to be about 10 to the 7. So it's the order that is important, not necessarily the real value. Now, this marks the end of our part 1 video. Let's meet in part 2.